Hello, this is Miles from RepreZen, and in this video I'll show you the quickest way to get started with RepreZen API Studio. I'll begin by loading an example project, and once I've shown you around this I'll generate some stuff that will serve as inputs for a full service implementation. The first time you launch you'll see the welcome screen, which has a number of links. The example projects demonstrate different features of RapidML, the main modelling language used in API Studio. I recommend you take a look at them all. But for this video I'll use the Tax Blaster example, which is the simplest one in the list. All the other examples elaborate on this one. The Tax Blaster example describes an API for getting and updating information about tax filings, including who each tax filing is for. Now that the Tax Blaster example has loaded, let's take a quick look and see what we've got. In the middle is the Rapid model, opened in a custom editor. And on the left, we have the Project Explorer, which shows the contents of our RepreZen project. The Rapid model is here, and this folder contains what we call gen targets for generating different kinds of outputs from the model, and I'll come back to these later. Below this, we have the outline view, which shows the structure of our Rapid model and provides one way of navigating it. And on the right we have the diagram view. This provides another way of navigating and understanding our model. It shows the resources in our API and how these are structured and linked together. Behind this is the documentation view, with end-user documentation generated from the Rapid model. And finally, we have the Swagger UI view, which enables us to explore and exercise the API when the mock service is running. The Rapid model has two main parts, a resource API model and a canonical data model. The RepreZen approach to developing RESTful APIs starts with the canonical data types we're going to base the API on. These can be defined locally, as in this model, and or imported from an external model, perhaps one in an online repository. We then design an API that exposes these, adapting each type to the specific needs of the API in question, a process that we call realization modeling. The canonical data model here is simple. It has data types describing tax filings and tax payers. Bear in mind that a real canonical data model would contain many more data types, and these would probably be much larger and more complicated than those defined here, with perhaps hundreds of properties. Since we wouldn't want to expose all these properties in all of our APIs, one thing realization modeling enables us to do is to exclude properties we don't need. Realization modeling is covered in detail in one of the other videos in this series. Most of the properties in tax filing are primitive types, but there's one reference property of type person, the data type describing the taxpayer associated with each tax filing. Let's move on now to the resource API part of the Rapid model. This describes a set of resources for working with tax filings and tax payers. The collection resources for tax filing and person enable clients to get lists of items and do bulk updates. We can see that requests and some responses have been defined in the methods. We can also see object resources for tax filing and person. These provide access to individual items of these types. And here's the link relation, or decorated hyperlink, for the tax filing taxpayer property. We can see how the whole API hangs together using the interactive diagram view. This shows how the resources are linked up and how each one exposes the type of data to which it is bound. The collection resources here and here serve lists of links to the object resources of the same type. These hyperlinks must be traversed to get details for each item in a collection. Let's have a more detailed look now at a RapidML resource definition. We can see that this is an object resource named tax filing object, which is bound to the tax filing data type. Here's the resource URI, and here's the explicit reference link which has been defined so that we can decorate it with a couple of properties from the target object resource for the person type. Such decorated hyperlinks allow API clients to get some information about the target resource without having to traverse a hyperlink, which is useful when populating HTML tables, for instance. This is just one example of the benefits of realization modeling. Note that this is a simple model. For more information about the Rapid modeling language and what you can describe using it, see the online language specification at RepreZen.org. Having explored the model, let's finish off by generating some outputs from it. RepreZen API Studio has a number of built-in generators or gen targets. These can be run from the Generate menu. You can easily define new ones yourself. You can see which gen targets have already been added to the project by looking in the Generate drop-down menu. We can add more via the File menu. You can see the full list available here, including JAX-RS for generating Java interfaces that can be used as a basis for a full Java implementation of the service described by our model. The diagram gen target creates a web page showing the diagram visualization of your API with full interactivity, just like the diagram view. So for the first time you can provide client developers with a dynamic graphical overview of your API. The documentation gen target creates API documentation using the same HTML format you see in the documentation view. You can deploy this to an API portal, a document repository, or any website. The JSON and XML schema gen targets generate schema descriptions of the data types used in your API, including specialized structures for each realization. And finally, the gen targets for RAML and Swagger translate our Rapid model into these popular API description languages. Thanks for watching this quick overview of RepreZen API Studio. For more detailed information on the subjects I've covered here, please see the other videos in this series.